Welcome to this presentation on cathodic protection. We hope that you find this time well spent and very informative. My name is Chad Ackner. I'm the Technical Service Advisor for Dealers LP Equipment and the R.E. Michael Company. R.E. Michael has corporate headquarters in Glen Burnie, Maryland, while Dealers LP Equipment has locations in Davenport, Iowa, Louisville, Kentucky, Hickory, North Carolina, Jackson, Mississippi, Dothan, Alabama, and also Memphis, Tennessee. It's important to note that anything discussed today should not in any way be construed to override any of your local applicable codes, any of your insurance requirements, or any of your company policies. Anything referenced today is from NFPA 54 and also NFPA 58. All propane installations must comply with both NFPA 54 and NFPA 58. Those installations must also comply with your local AHJ, or authority having jurisdiction, which may be a local code enforcement agency or a fire marshal. Company policies must always be followed, in addition to following manufacturer's instructions. Part of the code is to actually follow the manufacturer instructions, whether it pertains to NFPA 54 or NFPA 58. So that is actually written into the code. Always work safely, document everything that's performed during the installation or during the service work, and retain all documentation. A breakdown of the differences between NFPA 54 and NFPA 58 are that NFPA 58 will cover everything from the container all the way up until the outlet of the delivery regulator. Now that may be an integral twin stage regulator or a second stage regulator. NFPA 54 covers everything from the outlet of that very same regulator all the way inside the building. Today we're going to talk about cathodic protection and how that system protects underground propane containers. We're going to discuss installation practices and also testing procedures. The 2020 edition of NFPA 58 requires that a corrosion protection system be installed on all new installations of underground steel containers. This corrosion protection system should consist of a container with a coating that complies with section 5.2.1.11. Now, the containers that come from the manufacturer already have this coating in place. In addition to that coating, all installations must have a cathodic protection system that consists of either a sacrificial anode system, which is the system we're going to be explaining and discussing today, or an impressed current anode, which traditionally is used for larger, more industrial type of accounts. Also, in addition to the system being installed, a means of testing that system is required. And we're going to go through not only the details of how to install a cathodic protection system, but also how to test it by the standards set forth in NFPA 58. Some of the terminology you may hear, and some of which we're going to talk about today, are as follows. We're going to talk about an anode, and in this case it's going to be an anode bag. An anode bag, or an anode, is an electrode where the oxidation or the corrosion will take place. In other words, the magnesium anode will sacrifice itself to protect the steel components of the tank. We're also going to talk about a cathode. A cathode is basically a protected tank in a completed system. And the way they describe it is an electrode at which the reduction is occurring. In other words, we're not or reducing the corrosion that's occurring at the container. This is the electrode at which protection occurs in the cathodic protection system. So in other words, a protected container or protected piping, steel piping, in an underground propane installation is what's considered to be a cathode. We're also going to talk a little bit about corrosion, which obviously, when we're talking about steel, comes in the form of rust, and that's exactly what we're trying to prevent. We're going to mention electrolyte. What is an electrolyte? It's basically the common environment in which both the cathode and the anode share. So in this case, the tank or the protected tank, which is the cathode, in addition to the anode, which is the magnesium anode bag, are both sharing the environment of the soil. So in this case, the soil is the electrolyte. This is all part of the galvanic series, and magnesium is part of the anode that we use to protect underground propane containers. So these are some of the terms that we're going to be discussing, and you will hear going forward as you begin to get more into cathodic protection. Corrosion of a propane container obviously is a very aggressive form of rusting. Rust, when we're talking about underground propane tanks or underground steel piping, can be catastrophic. So that's what we're trying to prevent. We're trying to prevent that system from becoming so corroded or deteriorated to the point of failure. And that's what a cathodic protection system is all about. Minor surface rust can be very common and quite frankly may not be as big of an issue initially. But that mild surface rust, if not treated properly and not maintained, can quickly become a more critical problem. Over time, that superficial or surface rust can become a deeper, more pronounced corrosion, and it will ultimately form pits or pitting in the surface of the container. That's when the container will break down and potentially cause a more dangerous situation. When you consider cathodic protection, consider that there are really two lines of defense. The first line of defense is that coating that we talked about a few minutes ago. That coating is required to be installed on any underground container before it goes in the ground, before it's backfilled. That coating is provided by the tank manufacturer. So that would be considered to be our first line of defense against corrosion of the underground tank. The second line of defense would be the magnesium anode bag. And this is the anode that is connected or should be connected to every single underground tank installation. The anode bag will act as a sacrificial component to this entire system and will actually accept or receive the corrosion instead of the steel container receiving the corrosion if it's properly installed. There are really two ways to cathodically protect underground propane tanks and piping as well. The most common way by far is with magnesium anode bags. So I talked earlier about the option of also using what they call an impressed current, but that is generally used in a larger type of an installation, a more industrial type of an application. So what we're going to concentrate on in this seminar today is basically talking about and instructing you on how to install and test magnesium anode bags. There are many different types of anodes, but the most popular ones used in the propane industry are standard potential magnesium and also high potential magnesium. Magnesium alloy and zinc can also be used, and we're going to discuss a little bit about the differences now. Some authorities having jurisdiction will recommend a high potential magnesium anode, which has a voltage of minus 1.75 volts in places that have a more dry climate. For example, parts of Arizona, New Mexico, Texas, places like that. You may have an authority having jurisdiction which will require these higher potential anodes be used. You also may have locations near the coastline where an underground tank is installed next to a body of water that may contain brackish or salty water. In those cases, it's possible the local authority having jurisdiction would recommend a zinc anode bag. However, in the propane industry, the standard minus 1.5 volt magnesium anodes are generally used. That anode will work in most any type of soil condition in the United States. There are a few exceptions that as I said earlier, the high potential magnesium or the zinc may work better, but for all practical purposes, the standard minus 1.5 volt magnesium anode is what is required in the propane industry. The purpose for installing anode bags on underground propane containers is to protect the integrity of the tank or the container. What it will do is prevent corrosion from happening to the tank. It'll do this by acting like basically a light bulb lighting up the surface of the tank. This will basically happen because all of the electrons will flow from the external magnesium anode along a wire into the steel tank, which, as I referenced a little while ago, in a protected system is now referred to as the cathode. So it's basically an entire balanced system which will result in the magnesium anode bag, once it's connected to the underground container and backfilled, protecting that container. I mentioned that the code requires not only the installation of the cathodic protection, but also a way to test it. And testing it is really as simple as a digital multimeter and a copper sulfite half cell, which I'll get into in a little while. You can see in the chart on the right that different metals have many different voltage readings. But we're really concerned about steel and what they're classifying as mild steel, which is clean and shiny. That has a voltage reading, naturally, that is around minus 0.5 volts. A reading of minus 0.5 volts on your meter when doing a test is an indication that the tank is currently unprotected. Any reading below minus 0.85 is an indication to the person doing the test that there is work needed to be done on the cathodic protection system, and that currently the tank is not being protected properly. To do this, we must get the electrons to shift. And we're looking for a reading that is going to fall somewhere between minus 0.85 volts and minus 2 volts. Somewhere in that range is what we're looking for. Once we have that reading, that good reading on all four sides of the tank of minus 0.85 to minus 0.2 volts, we know now that we have a protected underground tank. And that is what we call a cathode. That is a protected piece of equipment, a protected piece of steel in the environment that's shared with the magnesium. So the tank now becomes a cathode. It's fully protected. And the length of protection really depends on a few different things. Has the tank been prepped and installed properly? And also, what are the soil conditions like? If the tank is installed in a dry, sandy type soil, it's possible it could last for years and years. However, if the tank is installed in a more corrosive type of environment, maybe more of a wet clay type soil, or in a more acidic type soil, whether it's at a landfill or possibly a agricultural type of an installation, those things will really dictate the length of the effectiveness of the cathodic protection system that you put in. We're going to discuss installation procedures of cathodic protection systems and also the testing procedures. But first, it's a great reminder to point out that it is important before any digging is done, whether it's for the tank or the gas piping, to make a quick phone call to 811, which will notify utilities of work that will be done in the areas that they service so that they can come out and they can mark the ground to verify that when the tank is dug or the piping is dug for the tank, that there are no utilities in the way. For example, water, cable, gas, any other type of installation that may be there will be identified, and it will tell the installer that they have a safe location to begin the project. It's also important to note that when we're preparing for the installation, generally a 500-gallon underground tank will receive a single 17-pound anode bag. If we're installing a 1,000-gallon underground tank, generally speaking, two 17-pound anode bags will be connected to that tank for proper installation protection. For 1,000-gallon tanks receiving two anode bags, it's important to place them on opposite sides of the tank at opposite ends of the tank, and both being set out about 2 to 3 feet from the tank. One of the tech tips included in the Dealer's LP catalog is on cathodic protection. It includes a brief summary of installation instructions, including the number of anodes required for certain size tanks, in addition to where they would go with regard to placement next to the container they're connected to. Getting back to what I originally called the first line of defense, it's important that any nicks, chips, or scratches in the tank coating is touched up before that tank goes in the ground. Oftentimes during transit, whether it's from the manufacturer or to the job site, the coating on the container can become damaged. That is not something to overlook. It is very important that any chip or scratch or any imperfection in the surface of the coating whatsoever be touched up with an approved coating, whether it's a touch-up can from the manufacturer or it's a different or an alternative coating that's available more locally, perhaps at a hardware store. This is a great example of what can happen if an underground tank is not prepared properly before it goes in the ground and gets backfilled. Again, this is where the importance of making sure those chips and those nicks and those scratches get touched up. This example took place not long ago, and basically what happened was this is an example of a tank that was installed and there was an imperfection in the coating. Maybe it was chipped or nicked during transport, but regardless, this hole, this approximately 1/2 inch in diameter hole, was actually able to compromise this tank in a period of about 3 years. So in about 3 years' time, this tank went from being brand new installed in the ground to having a 1/2 inch diameter hole essentially burned through it from the corrosion. Once we've made sure the tank is ready to go, there's no imperfections in the coating, and we get it installed in the hole in the ground, the next thing to do is to get the anode or anodes out of their original package, take them out of the plastic bag, or out of the cardboard bag or both and completely and thoroughly saturate the anodes. What this will do is it will activate them and prepare them to do the job that we're asking them to do, which is protect the steel container. So we remove the anodes from the package, we soak them in either a 5-gallon bucket by basically dipping them in, or we can saturate them with a garden hose to activate them and prepare them for installation. The next step is to place the anode or anodes in the hole next to the container and unwind the wire that comes with the anode. The next step is to take the end of the wire that's connected to the anode and strip the insulation off. Following that, we want to loosen the 2 lock nuts that are attached to the threaded stud, which is welded to the side of the riser on the underground tank. Once we do that, once we loosen up those 2 lock nuts, it should expose bare steel from the threaded stud. Once we do that and we expose that bare steel, we take the copper wire and wrap it around that threaded stud and then take those 2 lock nuts and retighten them against the copper wire. Basically what we're doing is we're making sure we have good continuity between the end of the copper wire and the steel stud, which is again welded to the side of the riser. Years ago, it was a requirement to actually CAD weld the copper wire onto the underground tank. Vast improvements have been made in the way to connect anodes to containers, and that is just one of them. There's no longer the welding requirement or the welding component requirement any longer to attach a magnesium anode to an underground steel tank. So that's something to celebrate for sure. I mentioned the importance of wetting and activating those anodes before they were installed to make sure that they're communicating with the soil and the tank properly and making sure they're working properly. Well, in parts of the country where it's very dry, has a very dry climate, it may be necessary to install extensions on top of that anode or those anodes in which water can actually be poured down onto the anodes. For example, in a dry climate, once that sand or that soil is backfilled, it's very difficult for those anodes to receive water and stay wet. So in those cases, the authority having jurisdiction may require the installer to install a 2-inch PVC pipe on top of each anode that's installed in the installation. This would require periodic servicing of this installation by the service company having to pour water essentially down those pipes and then placing a simple PVC cap over top of the pipe so that that moisture did not evaporate back up out of the pipe. That may be one simple way to maintain water and moisture in the vicinity of the anodes after an installation is done. Again, this is not something that all communities would have to do. It would strictly be an option or possibly a requirement depending on the AHJ in parts of the country that are very, very dry. And on the flip side of the dry climate, we have the colder, snowy climates in the northern and the northeastern part of the country. In those areas, it's a requirement that those underground tank installations be marked with a pole or a flag or something denoting where the tank is. For example, through traffic, landscapers, snowplow drivers, anyone driving past that tank, whether it's to park their car in their garage or to do some sort of service work at the site, must be aware at all times of where that underground container is. When anodes are sized for an installation, they're generally sized to protect the tank and the tank only. In installations where metallic tubing is used, for example, if an underground tank is installed with a roll of copper tubing from the first stage regulator over to the second stage regulator at the building, it's important to install either a dielectric pigtail at the service connection on the tank or a dielectric union at the outlet of the first stage regulator. What this will do is it will basically isolate the tank or the container from the underground metallic tubing. Remember, if underground metallic tubing is connected to the tank and there is no dielectric isolation, then what you're now asking the anodes to do is protect the container and all of the metallic tubing or piping underground. So you're putting an extra burden on those anodes, which were originally sized for the container only, or to protect the container only. You're asking them to protect the entire system, including the piping. And that will probably result in those anodes degrading prematurely. It is required in NFPA 58 to cathodically protect not only the underground steel tanks, but also any underground black iron or steel piping that is installed underground. Now, a lot of that is connected to the container. And there are ways that anodes can be sized to be installed at the container to protect not only the container, but the steel piping it's connected to. They are somewhat rare installations, but steel piping is used in the propane industry underground. And a lot of times it's used for agricultural applications or light commercial applications. We do have a calculator available that can determine if a customer wants to size underground steel piping and an underground steel, obviously propane tank. We have a calculator that will size the anodes required for that job. NFPA 58 also states that it's required for a dielectric union to be installed above ground and prior to entering the building of a system where underground metallic tubing has been used. So for example, as we discussed earlier about installing the dielectric isolation at the container to separate that from the underground metallic tubing, it's an actual requirement in the code to install a dielectric union, whether it's a shutoff, a regulator inlet, or a standard dielectric union at the building, above ground, and prior to entering the building. We've spent some time talking about the installation procedure of cathodic protection as part of the code, but part of the code is also testing the system once it's installed. And really all we need to accommodate that is a digital multimeter and a copper sulfate half cell. Dealers LP sells a kit actually that has the meter, the half cell, all of the extended wiring, documentation booklets, and also a plastic case that houses the kit. And it's a very handy tool to use when you're doing cathodic protection tests. When testing is performed, the first step is to moisten the ground at all 4 locations where the testing will take place. In other words, we want to wet the soil on all 4 sides of the container. We want to take the copper sulfite half cell and basically touch the earth or the electrolyte where the container sides are. In other words, directly below the surface of the soil or the sod. Once we've moistened the soil or the sod on all 4 sides of the container, we want to take our digital multimeter and set it to the 2 volt or 20 volt DC scale. The next step is to take the positive lead that's connected to the multimeter and connect it to the brass multivalve. What I would generally recommend is to remove one of the Acme caps and place the alligator clip on one of the Acme threads to make sure it holds. The negative lead would then get connected to the copper sulfite half cell or the copper electrode. The next step would be to test the soil in the damp area, the wet area, above each side of the tank. We want to check all 4 sides. What we're looking for is a reading of between minus 0.85 and minus 2 volts DC. We understand that the tank, which is the cathode, and the anode have to be in the same environment in order to work properly, the same electrolyte, which is the soil. But in this case, the image on the left appears as though an underground tank was covered with a concrete pad. When going to do the test, it's important to know that the copper sulfite half cell or electrode must also be testing the same environment or the same electrolyte as the tank and the anode share. So with this in mind, will the installation on the left work? For testing purposes, the answer is no, it will not work. The copper sulfite electrode must test the same electrolyte or the same environment that the tank and the anode both share. If we take the unprotected tank voltage value at negative or minus 0.50 volts, and we then connect the magnesium anode with a minus voltage of negative or minus 1.5, what we're looking to do is average that number out somewhere in between. So ideally what we're looking for is a number between minus 0.85 volts DC and minus 0.2 volts DC. If the numbers that you are getting when doing the cathodic testing are not sufficient, if they're below the minus 0.85 volts DC, there's a number of things you can do to troubleshoot the situation. Is the voltmeter turned on? Is the battery good? Sometimes these meters will sit on the shelf for 6 months or so in between tests, and batteries do go bad. Have you taken the rubber boot, the rubber protective boot, off the copper sulfite electrode? The end of the copper sulfite electrode is required to be placed directly into the soil. So it has to communicate with the soil. Are the leads connected properly to both the electrode and also the multivalve? Are you connected securely to both? Does the copper sulfite electrode have a blue liquid in it? Copper sulfite electrodes come with copper sulfite crystals, which have to be liquefied in order for the electrode to work properly. Have you set the electrode firmly on the ground? Have you poured a glass of water or a certain amount of water in the test areas on each side of the tank? Or is the ground dry? If the ground is dry, you're not going to get a good reading. And of course, are all of your leads connected properly, whether it's to the meter, to the copper sulfite electrode, or to the multivalve? Make sure everything has a good, tight connection. Any reading below minus 0.85 volts DC will indicate a bad reading, as shown in the column on the left. A good reading would fall between the minus 0.85 all the way up to minus 2 volt DC. on your digital multimeter, as indicated in the green column on the right. Any reading that you see that falls within this green column would indicate a fully protected system. There are times, however, when everything is done properly, everything's connected properly, and for some reason you still can't get the minus 0.85 volt reading and above. Well, we have a list of things to check if that occurs as well. Some additional things to look for would be, is there copper tubing used in this installation? Is there copper tubing that is connected through the dome to the first stage regulator? Is there a dielectric union or insulating union between the copper tubing and the tank? Or, quite honestly, it could also be, is there a dielectric pigtail installed? Oftentimes, if you have a tank installed with a properly sized anode system, those anodes are sized, as I mentioned earlier, only for the container. If you put the added burden of metallic tubing onto that system and you don't dielectrically isolate it between the container and the metallic tubing, you most likely will get low readings on your digital multimeter. That could be what's throwing your numbers off as well. If you install a dielectric union in that position, in that location, you may immediately begin to see better numbers. Another thing to check for is the coating. Is the coating inside the dome area peeling and susceptible to corrosion? That may be an issue. Is there a steel pipe with no dielectric union in the piping at the building? Maybe we're getting more of a draw inside the building on the system, on the cathodic system, because there's no dielectric union at the building. Is there electrical continuity between the multivalve and the pipe into the building? All things that we can check. Also, make sure that the anode wire is securely connected to the tank. Sometimes, depending on when the installation was done or how it was done, the wire from the anode bag can become loose or can get broken off or somehow become disconnected from the tank. Another reason that your readings may be low is because when the anode was installed, it was left inside the plastic bag. Something to consider. The anode may be dry. Maybe it wasn't activated properly with water when it was first installed, or maybe it's in a dry climate and requires continual water to be introduced in the environment of the anode. It's possible that it's an older installation and maybe the anode has been consumed. In that case, an anode would have to be added to the system. It's possible also that when the installation was done, the installer chose an anode that was too small. Maybe a 9-pound anode bag was installed on an underground 1,000-gallon tank. Even if the anode is in good condition, it still will not allow a reading on an underground 1,000 tank to be appropriate with a single 9-pound bag installed. It's possible that the anode is lying up against the opposite side of the tank. This is a common problem as well. Many times after a tank is installed, the landscaper or the homeowner will install shrubs or flowers or some sort of landscaping in the vicinity of the underground tank. Many people want to try to shield that lid or that dome. And when they do that, oftentimes they put a plastic liner or a weed block between the soil and the mulch or pine straw or whatever they're putting in. If that plastic liner is in place and the copper sulfite electrode does not make contact directly with the soil that the tank is in, you will not get an accurate reading. So make sure there's no plastic liner or weed block between the soil and the copper sulfite electrode. And the other thing to check for is to make sure that the positive lead is connected, as I said earlier, to the multivalve. not to the metal dome. If the tank has one, some of the older tanks have older metal domes. Even if it has a metal dome, do not connect it to the metal dome, connect it to the multi-valve. So those are all things to look for that could be contributing to poor readings. If you've gone through all your troubleshooting and you're still getting bad readings below the minus 0.85 volts, there are still things you can do to try to check the system. The first step is to grab a new anode that's the correct size for the installation that you're working on. Completely wet and activate that anode on top of the ground next to the underground tank installation. Next, you want to take the wire from the anode and connect it directly to the tank. The third thing you want to do before any digging is done is to make sure there are no utilities in the area. Make sure the ground is clear of utilities before the next steps are taken. Next would be to dig a vertical hole at least 3 feet deep. If this isn't possible, you may have to lay the anode down horizontally. Sometimes in dry environments, it's beneficial if you can actually go down approximately 18 inches, lay the anode horizontally in the trench. If there are water sources available, for example, sprinklers in the area that you could moisten the soil with periodically. If that's not the case, then what would be recommended is to install a piece of 2-inch PVC directly over top of the anode so that periodically water can be introduced to that anode to keep it activated and to keep the soil around the anode communicating well with that anode bag. Again, that's really more important in the drier climates and something that could be capped off so that after the water has been introduced inside the pipe, it doesn't simply evaporate back out. Once the anode bag is in the hole that you just dug, it's important to pour more water on the anode bag. In other words, you've activated already, but you want to introduce more water to the anode after it's in the new hole, and also you want to moisten the soil around the anode bag at the same time. Next, you would want to take the tip of a shovel and vertically cut the sod between the hole that you just dug for the anode all the way over to the tank dome. This will allow you to take the wire from the anode and press it down into the slot that you've just cut into the sod. The next step would be to take a cordless drill and drill a hole through the side of the dome in an area where there is no risk of hitting anything inside the dome cover or the shroud. We don't want to hit the riser, a regulator, a gas pipe, anything like that. We want to make sure we have a clear path through the dome into the dome cavity. Once the hole's drilled, we want to take a rubber grommet, install the rubber grommet in the hole of the shroud, and then pass the wire from the anode bag through the grommet into the dome of the underground tank. The next step is to connect the wire from the anode bag permanently to the threaded stud on the riser, or the anode clamp if you're using an anode clamp. Next, we want to take and backfill the hole where we just placed the replacement anode. So simply backfill the soil back into the hole and make sure that there are no voids or air pockets between the surface of the ground and the anode bag. If there are any voids or any openings or inconsistencies it will give the meter an inaccurate reading. So we backfill the hole with fresh soil, we make sure there's no voids, and then what I would do is I would water that hole down with a garden hose or a 5-gallon bucket or what have you. That will help that soil actually settle in that hole around that anode to make sure that you have good continuity and good communication between the anode bag itself and the surface of the ground where the copper sulfite half cell is going to be touching. And last but not least, recheck all of your readings, one on each side of the container. If you must, don't forget to moisten the soil in the test areas. With regard to underground piping, it's important to know that underground steel piping is required to not only be coated or wrapped, but also cathodically protected. It's recommended that copper tubing be coated as well, however, it is not required. Again, it's important to always check with your local authority having jurisdiction to verify these code requirements and/or exceptions. Regarding the installation of underground steel piping, it is a requirement in NFPA 58 to cathodically protect all underground steel piping. In years past, the only requirement was to cathodically protect steel piping 1 inch and larger that was installed below grade. However, now all size steel piping, any size steel piping installed below ground is required to be cathodically protected. We do have a calculator in-house in which we can help you size and place those anode bags according to the system design, the piping run, and also the size steel piping that you'll be installing below grade. And don't forget to wrap the steel fittings. Oftentimes these can be overlooked as part of the cathodic protection installation, but wrapping and protecting the steel fittings is just as important as wrapping and protecting the steel piping. So far we've talked about the installation and connection of cathodic protection for underground storage tanks. We've also talked about how to test to make sure that that installation is still protecting the underground propane tank. NFPA 58 also spells out the testing parameters with regard to who does it and how often it's done. Rather than read through the wording of the code, I've broken it down into a few simple steps. Testing, as per NFPA 58, is required to be done upon installation. In other words, when the container is installed in the ground, unless the weather conditions do not permit. And if so, it must be done within 180 days of installation. After that initial test, it's required to again be done within 12 to 18 months after that initial installation. This basically just verifies that the underground container is continuing to be protected. After 2 successful tests, it's allowed to be retested in an interval of time not to exceed 36 months thereafter. So for example, the container is installed, the container is tested. 12 to 18 months, it's tested again. With 2 passing tests, we now are allowed to go 36 months or 3 years after the second passing test to once again verify that the system is working and do a third test. Any failing system should be repaired as soon as possible, as worded in the code. If weather conditions do not permit, again, it must be done within 180 days after the failing test results. If a system does fail, it is required that the testing must be restarted, basically similar to the new installation requirements. Equally important to all of this information is that documentation of the two most recent test results must be kept on file for that customer. So how does the code spell out who can do the testing? The testing can be done by the propane company who owns the tank, by a separate testing contractor, or by the authority having jurisdiction. My guess is that most all of these tests will be done by local propane companies. But again, the code spells out exactly who may be responsible for getting these test results. Understand that NFPA 58 does not assign responsibility for testing or any other procedures. They say that basically any competent person can test the anode. We've spelled out who may test the anode, but part of the question also becomes, how does a delivery person know the tank that he or she is about to fill has been properly inspected, and if so, is it passing or failing? One way to do this is with a tag being placed on the tank that was just inspected. Many organizations are using color-coded tags to communicate better with the drivers. For example, maybe a white tag would indicate that the underground tank has passed inspection. It would also include the date that the tank passed inspection so that the driver would automatically know that 36 months from that date, the tank was required to be tested again. Maybe a failing container would have a color-coded tag similar to a orange or a yellow or red. A color-coded tag would indicate that the container failed and that the driver should not fill that until the cathodic protection has been repaired or replaced. I mentioned before that underground steel piping is required to not only be wrapped and protected, but also cathodically protected with anodes. This may be difficult because there are many different sizes of installations, whether it's pipe sizing, piping configurations, distance from container to the building or to whatever piece of equipment is utilizing the propane. There are calculators that we have for sizing the proper number of anodes for any underground steel piping application that may come up. One of the nice things about using the handbook is that it provides a better description of certain sections of the code to help explain why the codes are in place. It also goes on in certain areas to explain potential incidents that occurred in the past that have led up to why this code is now a requirement. If underground steel piping is part of the installation and therefore cathodic protection is required for that piping, one way to attach that anode bag to the underground steel piping is by CAD welding it. Another means may be to use a clamp, an anode clamp. Sometimes a simple cable clamp can be used for underground piping retrofits or underground piping installations. One example of an anode clamp which can be used on either underground steel piping installations or underground container installations, particularly where containers were not built with the threaded stud, which is in more modern tanks, welded to the side of the riser. Older tanks did not have that feature, and therefore to retrofit an older container with an anode bag, whether you're adding it for the first time or replacing it, 10LP1391 is specifically designed for that purpose. We also have a complete anode test kit. This is a kit which comes in a very sturdy plastic case. It includes the copper sulfite half cell, the copper sulfite crystals, a digital multimeter, 2 extended leads, a laminated instruction sheet, and also a documentation pad for each test that's done. The catalog number for this complete kit is 10LP5791, and my suggestion is to have at least one of these kits in the company. And also anode bags, whether it's a 17-pound bag, 10LP1386, or a 9-pound bag, 10LP1390. Both of these sizes are very popular in our industry. Remember, a 9-pound bag will handle a 320, a 250, and a 120. A single 17-pound anode will handle a 500, and 2 17-pound anode bags will handle a 1,000-gallon underground tank. For more information on cathodic protection, go to propane.com and check out the Cathodic Protection Training Guide downloadable PDF. To finish up this presentation on cathodic protection, we have some Q&A. First question, the most commonly used anodes are made of what? The answer is magnesium. True or false, after placing in the ground, anodes should be kept dry? The answer is false. Question 3. How many sides of a tank must be tested? The answer is all 4 sides. True or false? Anodes must be tested only once after installation. The answer is false. Last question. What is considered the first line of defense against corrosion? Tank coating. I want to thank you for watching this presentation on cathodic protection. Hopefully you understand the process of cathodically protecting underground propane tanks better than before, and hopefully you can use some pointers and information you've learned today during this seminar going forward. Thanks very much. Take care and have a great day.